My presentation today, I'll run through some brief information about SGS. Again, I'll make the point. I'm not a business development person. I'm not a sales and marketing person. I am a lab professional at heart, and obviously this is a large part of our business, but it's really important that we manage to keep going forward. Here we go. Okay, so we're going to go through basically fit for purpose. Right, we hear a lot about fit for purpose in terms of the laboratory space, but what does it actually mean? Give you a little bit of background on SGS, and this is probably a scale type thing with part of my presentation and the sort of level of information we're talking about. SGS globally, as I said, we're a huge company, almost 100,000 staff, probably over that now, Mark, I suspect, as we're sort of ticking along. There's still continued growth. 2,650 plus offices and labs globally, and numerous industries, not just the mining side of things, obviously pharmaceutical, environmental, actual textiles, all sorts of different testing. Anything testing and verification you can think of, SGS will be doing it somewhere in the world, not necessarily all here in Australia. As I said, testing facilities everywhere from on-site. So we do run on-site labs for mining companies. We go in as a contract laboratory, but obviously, again, whether there is a contract laboratory, some of those laboratories will be on the site for 15 plus years. Effectively, we run the site really hand in hand with them. It's a contract laboratory, but we like to sort of think that it's still their laboratory to a degree. Commercial labs, obviously big hub labs where lots of volume samples come in and have lots of diverse work. And again, this sort of feeds further into things like we've got fertilizer labs, metallurgical facilities, mineralogy, environmental labs, you name it. We've got a lab for it somewhere in the world. And with that, obviously, comes lots of information, lots of challenges around things like fit for purpose, because we don't have one. We're not an iron ore mine where we've got iron ore going through and that's it. We've got hundreds, thousands of different things going through. So how do you work out, well, what is the fit for purpose analysis that's required? Yep. Stay on to there's the map. Lots of dots. I'm sure Mark Davidson from SGS will probably tell me we've missed somewhere, as it's continually getting updated. But as you can see, we've got a huge global footprint in terms of laboratories. Again, just a bit about myself. As I said, yeah, basically I've been in the industry since I went into chemistry and went to uni. When I finished uni, came out and I've worked on mine sites. I've worked in commercial labs, which is probably the mine site work in particular is something that has helped me, and it's something that I'm relatively passionate about in terms of certainly trying to develop new people and get them understanding. Is to work in a commercial laboratory, you're just in this little microcosm. It's just really this one little place. You're not actually seeing, where did the sample come from? What are they using it for? What's that great big processing plant, and what on earth does this sample actually mean, and what should it look like? And if it looks like this, what is that actually telling me? And then how do I know what analysis I should be using for? A lot of that doesn't just directly come out of a book. A lot of it comes out of other things. So how to determine fit for purpose, right? So classical definition, right? You've got to define criteria with metrics like accuracy, precision, detection limit, and gather measurements relevant to the method. Then compare against predefined criteria to determine if the method is fit for purpose. So we've got our calculations there around how we're actually going to calculate things like the mean error, the percent error, our precision, our standard deviations, the detection limit, the specificity. Good news is this is not what we're going to look at today. Now that everybody's scared, going, oh crap, he's going to go on about statistics. This is going to be really dry. No, it's not. They're really important, and we know that we need to do them as laboratories. And for accreditation and for understanding what our detection limits are, is it fit from that perspective? That it is important. However, it's not necessarily going to tell you whether the actual test itself is fit for purpose, because you need to define what it is in the first place. What is the purpose? Again, this is a bit of my personal passion and spiel, right? But the lab should be the technical experts in regards to the analytical chemistry and the methods. And we're more often than not, we're not the end user of the data, right? Yes, we are the experts in the methods and the analysis. However, we're not the end user of the data. So to determine these things, we've got to actually engage that sample owner. We need to understand the end use of the data. So we need to understand things like when a geologist has a drill hole, I've got a whole set of data from it. Well, actually, you know what? I know that they do a block model, and I can have a look at the data and go, well, something looks really anomalous there. Something looks out of place. I can see if they're going to map it, they're going to go, there's all this grade and there's one sample in the middle that's got nothing. Well, we should check that. Now, you don't know that unless you understand some of the geology and understand how they're using the data. You don't know that. So one of the really important things is, as I said, to understand the end use of the data. Same from the processing plant point of view. Same thing. What are they using that data for? What's important to them in that data? Otherwise, we can't select the right method for the actual purpose. More importantly, for the purpose of the end user, not the purpose of the laboratory. So two-way communication is key. Before we go any further, can I have the hands up from the geologists in the room? Metallurgists? Okay, just so I know who I'm going to alienate somewhere along the line here. No, it is really important to get that really broad spectrum of the views, and more importantly, what are they using the data for? As I said, at the end of the day, more often than not, the laboratory is not actually the end user of the data. So we need to engage that end user, and we need to understand what is it the data is going to be used for to be able to then help select the correct methods. Sometimes it might even be developing the methods, but you need to understand the end use of the data first. So as I said, the fit for purpose is not a pure calculation. Yes, there's statistics, there's things we need to do to ensure that we're actually meeting those, but it's not just a pure calculation. That is not going to determine whether that is fit for the end user's purpose. Discussion between the lab and the end user. This is always a fun one. Again, as I said, what's the end purpose of the data? Is it greenfields exploration? Are we talking about brownfields, resource definition, grade control, process control, geomet test work, final product or shipment settlement analysis? These are the general things that you can use as a starting point as to, well, where do I start? How big's the program of samples? Is it one-off? Is it regular low volume? Is it regular high volume? Those things are important because you won't necessarily come up with the right fit for purpose solution without knowing that information. What I like to call the golden triangle: speed, quality, and cost. Which two of the three would you like a lot of? To get all three is quite often very, very, very difficult and very rare. I'd like it turned around in 1 hour. I want it a detection limit at 0.1 ppm, and I want it to cost me $2. Very, very rare you're going to find that, right? But most importantly, again, which are the important bits in terms of the fit for purpose? That's where you need to work with the end user as to, well, okay, what is it that they need? What are the critical things for them? So, yeah, it's a real world issue, and how to achieve this? And it has to be around those discussions with the owner of the data, or the end user, around, well, okay, what is it they require? And then you come up with that solution based around it. Said, what precision accuracy do they need? What turnaround time and what cost? Right. As I said, they're always interesting conversations that are had all the time. I want this and I want it really, really fast. Well, okay, we can give you some kind of compromise on that. You can use this technique, this method, which is going to help you do that. However, it's not going to have the same level of precision. And that's some of those compromises that need to be made. But most importantly, needs to be discussed with the end user and make sure it's fit for purpose. The complexity. this is a really high level view to start with. We get a request to analyze a sample and report zinc. Right. This is the sort of thing that comes into us all the time. Somebody comes to me and goes, Graeme, client wants us to report zinc. Okay, I'll go and have a look. We've got 115 separate methods we can report zinc off. Okay, this is now like a lucky dip if we don't have the right information and go and ask questions. So, and that doesn't even include client-specific ones, which we have lots of, where you develop something for a specific problem or a specific client. As I said, these are just standard ones, and also doesn't even include things like your ISOs and your ASTM. So you just keep extrapolating how many different options there is. So unless you've got any information, how do you understand which one you should be using? And most importantly, how do we help the end user get the right one? Because we're the laboratory experts, not the end user. And that's really the important bit. So as I said, without any details, any other details, it's impossible to select that right method that's fit for purpose. You just can't. You'd be a lucky dip. Going to use an example, this example of zinc analysis right through this. As I said, so yeah, the first questions. Is it exploration level and what type? Is it resource definition? Is it grade control, process control, geomet test work, final product, shipment analysis? So in other words, where are the samples being generated from, and what are they going to use them for at a very high level, and what's the sample matrix? Because we even get sometimes, I want this, and you go, well, okay, first question is, and it's invariably the first question I send business development salespeople back with is, can you find out what the matrix is? Like, what is it that we're actually going to get? Again, it's about going through that process. So exploration, and again, depending on those samples, you can then go, well, okay, we can start narrowing it down. If it's exploration, right, you tend to be looking for anomalies. You're not necessarily looking for a 100%, you're not looking for something that's going to be that precise. You're really just looking for an anomaly. Because what they want to know is, have I seen a blip? Okay, I'm now going to go back and I'm going to target a bit more drilling there because we have actually seen an anomaly. So those sorts of things, rather than just a zinc, if they've said they want, they're going to they might be targeting zinc, but they're going to probably want a full suite of 60 odd analytes, which means you're going to be looking at big ICP type work, things like that. And the precision is not going to be the same, maybe around about 10%, because really what they're looking for is a spike above background, so they know there's an anomaly. Let's go and have a closer look. And the turnaround time and those sorts of things. So the speed isn't as critical. Right? It's not a mine, it's not a processing plant. It's not as critical. Yes, they don't want 6 or 10 weeks lead time, right? And it's always pressure on turnaround time, but it's not, we need it in an hour. I said, along with the zinc, the example of zinc, yeah, they're likely to also want a suite of other Pathfinder elements. As I said, they might have just requested zinc, but now you have the conversation and you start teasing out, well, actually, no, they're going to want more than just the zinc when you understand what the end use is. And so they tend to be ones, again, you've got to go, well, okay, but what do they want to do? Because at zinc, they're probably going to have some resistive elements, so you start to have to look at things like fusion, ICP-MS type finishes rather than an aqua regia or even a 4-acid. And you might even look at some of your weak partial leaches like your MMI. Because again, it's just looking for anomalies is really the key. And then suddenly that reduces to about 5 different options. So you've gone from 120 something down to a much smaller suite of options that are available. Again, if it's once they then identify it, sometimes you've really gone out of your greenfields and you're starting to move a bit more, because I have seen some anomalies, so I'm now going to actually, I'm in a prospective area. I think there's some actual material there. I think that there's some mineralization. They might do a larger sampling program, smaller pattern, but a larger number of samples, and then you might start using some things that aren't necessarily total, like your fusions, because they might go, it's okay now, I know it's there, I'm now only just targeting these. So you might start looking at those. Why would you look at those? Purely because it's cheaper. To be brutally honest, it's fast, it's cheap, but again, it might be fit for purpose at that point, because they're now knowing, okay, I don't need to do the full lot because I'm not really worried about the resistive elements, I'm just targeting on these. Again, the end user needs to be informed of those limitations. That's the other critical part. I've seen it numerous times. They'll go and pick the cheap method because it was cheap. get results and go, why is it that I'm seeing issues on chrome? Why is it that I'm not seeing total on the barium? And you're like, because you didn't tell us that they were really critical to you. And guess what? No, they're not going to be total on those methods. But it's important to tell people up front that information so they can get the right method, again, fit for purpose. With the exploration, obviously, there's newer technologies out there as well and other things that can start being applied, particularly once your target's identified, right? So you can start doing things that are going to be, again, probably a bit faster and are going to give you some different information. Faster because you're not necessarily doing digest things like your PXRF, your FTIR, and your NIR, which are going to give you, yes, they're going to also give you a little bit more mineralogy information, but they're also going to be fast and they can be basically done on prep samples, all sorts of different things. So again, fit for purpose. Suddenly that might be more applicable to them, depending on what they're targeting. The resource definition side, right? The objective of resource definition is to determine if the mineral resource is economical in terms of grade and size. So guess what? They must have a greater degree of precision than your exploration, because suddenly it becomes more important. I'm not just looking for, am I looking for an anomaly and somewhere else that I've seen a target? I'm now looking for something where I actually really do need to have a better precision and accuracy on it, because this is now about actually defining that resource. Again, the example of the zinc, you start to target a smaller suite of analytes. So you might not do the whole 62, the whole periodic table. You can then start actually looking at defining the ore body, looking relevant elements like your zinc, lead, sulfur, silver, bismuth, iron, copper, and there might be others depending on the mineralization. Again, you then do start looking, again, you're not going to use something that's not going to give you a total number, because guess what? You need to actually define that resource. So you need to be looking at methods that are going to do a total analysis. So you start looking at things like, again, your fusion, potentially XRF as well. If you're not looking, again, you might not be now looking at ppm, low ppm levels, looking for a signal. No, now I don't really care so much about those. Now I'm actually looking at my resource. So I'm looking at those grades that are higher. So you look at those methods. So your OES rather than MS and your XRF. Basically, and sometimes, yep, you're going to need to use multiple methods to cover a large enough dynamic range at this point. Because you may go, well, okay, I need to use low-level methods for some of those analytes, particularly things like your silver, your bismuth. But guess what? I actually look the iron, copper, lead, zinc. I'm actually going to have to use higher grade methods because I'm now looking at such a large dynamic range. Again, has to be a conversation with the end user. What are they trying to achieve, and what are they expecting to see? The grade control, again, once it's in production, analytical work is used to distinguish between ore grade and waste rock. So no longer are we necessarily talking about resource definition. We've got to remember with resource definition as well, that also needs to go through JORC and things like that. Right. So again, the speed of the assay is not quite so critical, but you've got to have that precision. Grade control. We start switching the other way again. Right. Grade control. I know I've got a resource there. I'm drilling it out. I need to know which particular bit is ore and which was waste to make sure I'm putting the ore in the mill and the waste going out to the waste dump. Now, I have to do that with reasonably rapid turnaround time. Can't be weeks because I don't have that much space in my pit. Sometimes it might be days, sometimes it might be 24 hours, 12 hours, depending on the ore body, how they're mining. But again, you need to talk to the end user. How rapidly do they need that data? Is it something they need in 3 days, 4 days, or is it something they need in 6 hours? That's going to determine how you go about the analysis. So again, the grade control, as I said, requires rapid turnaround time and does require the high precision methods generally, right? Because again, they want to make sure, because they're using that to determine how many tons of that ore is going up on the ROM pad, how much is getting fed into the mill, so it'll become part of the actual net balance and everything else. So it's important that you've got that precision. Okay, so they won't be that much different from your resource definition, except sometimes you might use a slightly more rigorous digest and not worry again about the really low levels, because you already got a resource, you're just trying to work out am I putting it in the mill or not. And there might be more targeted quality control at that point. So in other words, now I know I'm only really worried about the grade control, and this is the sort of mineralogy, this is the grades they see. You can start from a lab point of view, tailoring what you're doing from a quality control point of view even more. Again, including things like targeting cut-off grades. Really important to make sure you're doing that. Sometimes, due to the rapid turnaround time, you'll actually use screening tools, things like PXRF and F2R. Precision's not as good, but if it's going to mean I've got 1,000 samples, of which 300 I can do a really rapid, quick screening on and go, don't need to do the rest of the assaying now. It's waste, right? Done. Then you go and do the more rigorous methods on the stuff that you now know, okay, this has got grade, we now need to define this, or it's above a certain amount. So again, it's about talking to the end user and understanding what they want out of the data and what is critical to them. What's the cutoff grade? Things like that, right? When you're talking grade control, it's really important to have those conversations with the geologist and the Mets around, well, what's the cutoff grade, right? Do they care about the difference between 0.08 and 0.09%? Probably not. Or between 0.08 and 0.12? Possibly not. But if your cutoff grade's 0.4, they might be interested in the difference between 0.38 and 0.42. So you need to start targeting around those areas as well. I said, in terms of the zinc, be very much similar methods to what you're using. On your resource definition, however, you might start using larger masses and volumes to try and improve your precision, using things like actually using volumetric flasks, for example, opposed to using a dispenser for your final volumes, because you're just trying to, again, bring those things in a bit tighter. And again, those targeted reference materials is really key. The process control side, this is where it gets even more interesting, mainly because a lot of lab people don't have a great understanding of the processing plant. I'm not a metallurgist, never going to pretend to be a metallurgist. However, I spend a lot of time with metallurgists understanding their processes in the plant and what's important to them, because then you can actually work out what we should be doing from an analysis point of view. It's really important. So I said, samples taken within the mill used to control the processing plant, right? So you go, and the challenge there is you're going to go from basically tails, which is going to be really low, up to your concentrate. How are you going to get a method that's going to take you from one to the other? At 55% zinc, 0.02 doesn't make much difference. However, if I'm worried about tails, suddenly these things start making a difference, because it's all then about the met balance and their recoveries. So you need to understand where are the important points, where do you need those. Sometimes it means you have to use different methods for your tails and your concentrates and your head grades. But it's all about having the conversation. I said, and even within that, it comes then down to speed. Right? The material's going through the plant. It can't wait a week to give you a result. I need to know what's happening now. Spot samples, right? Always really urgent. We want them in a couple of hours, right? And then you got your shift of daily composites, which they use for their met balance generally. Won't necessarily be quite the same speed as spots, but how do I then do the spots so quickly, right? It's then about, again, having the conversation. What's the important thing for the end user? Hey, you know what? I need a list of 10 analytes for my met balance, but on my spots, in other words, how I'm controlling my plant, no, I don't actually need all that. I just want an iron and a lithium on a lithium plant, for example, right? I'm not worried about the others on the spots, because that's not how I'm controlling my plant. So quite often the spots will have a smaller suite of analytes, and you won't use all the methods if you can, because it's about then, as I said, trading off to get that speed. And the met balance always requires a bit at that degree of precision accuracy, because they're going to use it to determine the recoveries and concentrate grades. Quite often, actually determine what they're going to be shipping. In the zinc, again, sort of same sort of thing. Spot samples may be done by fusion XRF, as the zinc's used to control plant. However, no fusion ICP done, as the silver and bismuth aren't used for the process control. So in other words, you drop that off. I'm just going to do this one technique now for the spots because they need it rapidly. Then I might need to do both to be able to do that. What you tend to find as well as a lab, you then actually ramp up the QC, because guess what? I now need to be sure that my tails number right down below is right, and I also need to know that my concentrate number is right, and I need to know that my feed grade is about right. So suddenly, instead of you're upping your quality control rate, because you just need, but you need to target where those are based on what the end user is. concentrate and bullion analysis. High dollar value of concentrate and bullion shipments means that regular analytical methods used for other stages generally are not appropriate. What I'm talking about here is once you are doing the analysis, particularly once we go into things like shipment analysis, some of those, the commercial analysis side, has to be very high precision accuracy because there's so many dollars attached to it. That 0.05% difference on the zinc, for example, could be a huge amount of money. So am I going to do a fast, quick analysis? No, I'm not, because I can't get that accuracy that's needed. But again, you need to talk to the end user to understand it. As I said, so on that end, yeah, they tend to be very high precision. So you're now starting to go, I want something that's got better precision than 1%. Whereas before you're starting off at 10%, you can sort of see how as you're going through, suddenly my precision's got to get tighter. But the trade-off is QC insertion is much higher. I'm generally going to do everything in duplicate or triplicate, which I'm not going to do on an exploration or a grade control sample. But on this analysis, yes, I am, because it's really important. And to get that extra precision, you need that extra QC in there. And yeah, you'll start running things like proofs and things as well. And they do tend to then be classical methods. There can be some XRF methods as well. But a lot of them on the actual commercial side become the old classical methods, which, as we all know, are not fast. So we look at the zinc, right? We can do zinc at concentrates by XRF fusion, but generally once you get a commercial transaction to the buyer-seller analysis, no, won't be accepted, and you won't get the right precision on it. And a lot of the contracts have it written into it. You have to do the classical zinc titration, right? Which an EDTA titration with corrections for residues and other interfering analytes can take a whole day to do one run, right? So it could take me a whole day to do 6 samples. Clearly, that's not going to work on a processing plant. Clearly, that's not going to work on grade control or anything else. But this is that trade-off between the precision, the cost, because obviously there's a lot of higher cost in this for that 6 samples, because one person is going to be consumed all day just doing that. And it will be somebody who is relatively experienced and highly skilled doing it. So I said, only small numbers of samples can be done at once. As you can sort of see through these examples, right, the end use of the data needs to be able to apply the fit for purpose analytical method. We need to understand what the client wants. I'll give another example. Obviously, with the zinc one, we can't apply that zinc titration to exploration because it'd be too slow and expensive, and we cannot apply lower precision, high volume exploration method the other way around to the concentrates. My big part of it is, as the lab experts, we should be directing the end user to that fit for purpose analytical methods. Just a show of hands from people, how many times as a lab do people come to you and go, here, I want this analysis, without actually consulting you on, well, what is it they want? What is the sample? What do they want it for? It happens all the time. And we, as lab experts, need to actually take some of that back and go, well, actually, hang on. Yes, I can do what you're asking, but can you let me know what you're using it for? Because maybe we've got a better solution. Too often as labs, we're a bit like a fast food outlet, right? Somebody says, I want fries, well, here's your fries, right? But we're not very good at actually going back and going, what are you, okay, no problem. I can do that for you, but just to make sure that we're giving you the right thing and you understand the limitations, what are you using the data for? I'll give an example of, it was I don't know if anybody's used pulverize and leach before, the PAL. So basically, good technique, right? Basically, you put the sample in, you put the cyanide tablet in, it pulverizes it and leaches it at the same time, right? Then you get the liquor, you analyze it, okay, there's this much gold. Now, I saw a mine site who was doing it really well, no problem. Results look really good. The metallurgists thought they were the best thing ever because their recoveries looked brilliant until you went, well, your recovery's not actually that great. Your recovery's great of your cyanide leachable gold, because all it was doing was telling them in the tails, right? All it was telling them was, okay, I've leached out all the cyanide leachable gold. Yeah, my recovery is great. However, the feed grade that was going in at the front, the geos were doing that as a total gold number. So there's all this gold going out to the tails, which their assay did not tell them was going out to the tails. Their assay told them they had like 0.02 ppm going out to the tails. It was great. Until they did a total assay on the tails and realised it was more like 0.16, because they didn't look at the actual method that they were using to understand the limitation. Method was fine, and what got implemented after that was once a week they'd take the tails and get it sent off site to do a fire assay to get a total gold opposed to a leachable gold, to understand what was actually happening. Again, it's about talking to that end user. As I said, to me, one of the things is it's how do we keep training lab staff up, which I'll be interested to see Ian's presentation, because a lot of this comes down to that experience about being able to engage with the geologists, with the metallurgists, and ask the right questions. And getting out, I hate to say it, getting out of the lab, getting out into the field, and going through a processing plant. I encourage any lab worker on a mine site, I always ask them the question, so have you been through the processing plant? Do the geos take you down the pit? And quite often the answer is no. And my next question is always, have you asked them? Right? Because invariably the answer is, well, not really. And it is about the lab engaging the end user. It's not just about the end user engaging the lab, right? And it really is important for the fit for purpose that we do a lot more of that, understanding what they're using the data for. We can come up with the best method, but it might not be at all fit for purpose or applicable to them.